Okay, good evening YouTube. So this is just a quick video. Excuse me. It's a quick video because I've seen quite a few videos of people building frames and whatnot on YouTube lately, and there's not so much right and wrong ways to build a frame, because I mean really there's no right or wrong way to fabricate anything, you know, as long as you get the sort of end goal and the end result. But there's ways to do things that are going to make your life a lot easier. Now, one of the main things that you see a lot of, and this isn't just on YouTube, you see it everywhere. You see it from experienced fabricators, you know, who have perhaps spent their life or their working life building perhaps smaller stuff, sort of bench stuff, and then move to one day they get a job and you know they're doing a big frame, and you can see you sort of see the sort of their experience size-wise come out in the way that they build a frame. One perfect example is when you start a new job in a lot of places, the first thing they do is go out to build a bench. Now, it may seem very simple, and generally, you know, it is, but you very often you notice a lot of the other people there will be watching you, you know, and whatnot, and the reason is watching somebody build a bench will tell you a lot about what they've done in the past, what they're capable of, what they may not be capable of, or perhaps you know where they're gonna get into trouble. So what we're gonna do is we're gonna just have a look at a few frame designs and where people sort of start. Not start wrong, but start somewhere that's going to sort of possibly get them into aggro later on. So this frame here, right, there's no dimensions on it, and there's a reason that there's no dimensions on it. Really, if we're gonna sort of develop or learn a method to make a fabrication, then really that method should carry through regardless of size, regardless of you know, whatever, and the only things that are likely to change are really the way you actually lift the parts and the way you move the component. So the first thing that a lot of people do, and it's not wrong, but it's I think it's almost you get focused on getting the top of this table square, right? Because it's the top, you know, it's the bit that everybody sees, you know, it's the top of it. So they want it cock on. So what they do is they lay this out, yeah, and they get this square, you know, in the corner here, and they get this perfectly, you know, square, beautiful top. And then it comes to putting legs on, and very often you're gonna end up this way up. So you're gonna be upside down here, and you're trying to put legs on here, and you see this a lot. You see this a lot from guys that perhaps don't deal with a lot of bigger stuff. And you can see I'm trying to put a square in here, and you know they're getting it right that way. Then you know they get a tack on there. Then they put in a square in there, and all right, they get it right that way, and they go back, check this side, and that side's out again. So you know you're trying to level, or you're trying to square up on two planes, right? Which is firstly very difficult, you know. Secondly, it's not necessary. You don't need to do it. You know, there's another way of doing this where you don't have to do that, and I'll show you in a minute with this frame why this method, you know, can get you into real trouble. When you start your frame, take the sides there and build this side, right? Right. A lot of people are going to jump straight for this. Yeah, it's just square. I would say don't bother. For this, it's not really, you know, the right tool to use. I mean, this one happens to be what, about 230 mil. All right, it's a 9-inch square. So that square is only ever going to be that accurate. Remember, we're dealing with steel section, yeah, which, as you probably know, is never ever straight. You know, over a 4 or 5 meter length, there's a good chance that you're gonna have some sort of bow in it, right? So if you're measuring, you know, let's say for instance this is, I tell you what, let's say this is 230 mil, right? So it's the same size as a square, right? So it would work, right, in this case, yeah, for that leg, right? But then the problem arises then when, obviously, if this then becomes 2,300 mil, you know, unless you've got a real big square, it's not gonna, you know, be a great deal of use to you. That's why, you know, it's better to learn this method. Yeah. Sorry, right. That's why it's better to learn this method, and you know, it's not gonna matter if that's, you know, 23 mil, 230 mil, 2,300 mil, you know, or 23 meters, it still works. So what we're going to do is we're going to take out 2 legs and we're going to lay them out on our flat surface. Now, very often in the shop you've got a flat bench, or you'll have a flat area, or whatever. And sometimes on site you have they build beds, you know, out of column or out of channel, you know, to give you this flat area. This has got to be flat. You know, they got to be flat. You need to run a level on them to make sure they're both sitting on the same plane. If they're both out of level, doesn't matter, as long as they're both out of level the same way, right? And then what we're going to do is we're going to take our tape measure and we're going to measure there and there, and these need to be equal at whatever dimension it needs to be, right? Then we're going to take our tape measure and we're going to measure diagonally, yeah, from corner to corner, and they also need to be equal, yeah. Then we know that these are parallel, yeah, and that this, when we put this top piece in here, that they're going to be square, yeah. And that doesn't matter, it doesn't matter then, as long as your tape is long enough to reach from there to there. It doesn't matter how big, you know, this is, you're always going to be square. And it's you know, it's real accurate, real accurate. If you put a square, if you put, even if you had, say, a imagine again that this is 2,300, even if you had a meter square, right, you're only going to be accurate up to about there. Now that's, you know, that's okay, but if this is bowed and it's bowed there, and you've got, you know, you've got a foot plate to meet up to there and there, and there's a bow here, you're not going to hit that plate. You haven't got to open out because there's a bow here that your square isn't taken into account, right? If you measure from corner to corner and do it that way, then it doesn't matter what's going on in between here and here. You know that you're right there, you're right there, right? Okay, so we've got our side done. we've tacked it up, very often it's a good idea to clamp these down. Once you've got it sat square and all these dimensions the same, clamp it down or tack it, or whatever you need to do to keep it there. Put a brace in there if you've got nothing down here, and then you can weld it. And then when you come to do the other side, all you've got to do is lay the other pieces on top of this one. You don't even really need to measure them. You just lay them on top, clamp them together and tack them. Right, so then we got 2 frames that look like this, and we're going to turn them upside down, and all we're going to do then is pop our cross braces in. Right, and then same thing again, we need to be on the same plane, so we need to be on this flat surface, and this time we measure there to there and there to there. Same the other end, just in case you've got a twist in it. And you know that frame then is going to be square. You can also then measure there to there and there to there. And there's no way then that you can be out to square. Now, the reason that the reason that this method, by building the top and then sticking legs on, doesn't always work is, for instance, this is a common sort of frame, possibly for I don't know, it could be a conveyor, something along them lines, you know. So maybe this is 1 meter, but this could be perhaps 8 meters, right? And you're not always going to have a cross brace in line with the leg, because all cross braces do is brace these 2 sides. Yeah, they don't have to be, I mean, you may only have 1 in there. So if we were going to use this method, you've got a leg standing up here and you've got nothing, you know, to square it off. Like I said, if you're in a workshop, you've probably got a plate. You've probably got a flat plate that that's sat on that you can put a square up off. Right, but if you're out on site, there's a good chance you've probably got 2 channels like that and like that you're working off, that have been leveled, and you're working off to build this frame. Right. Also, I hope it's clear. I hope it's clear. I've got a frame to build, so maybe I'll film it. This method will also work if you've got right, if you have this style of frame. Yeah, so you've got a foot plate there that you've got to pick up with. You know, the civils are put in, it's concreted in, you ain't got a lot of room to play on it. You've got 1 here that you've got to pick up on, and you've got, I don't know, perhaps a motor housing or something up here that's got to line up with a shaft. Right, so you've got to be pretty bloody close. Right, now you can come in, you know, we have a box section frame there. Now you can come in with your protractor and you can check that, right? But it ain't gonna help you if that's 6 meters tall. You know, it's not gonna help you in the slightest. But as long as you know this distance and this distance, then you can use exactly the same method by measuring from that corner to that corner and vice versa, and it'll tell you if you're true to that center line and that your dimensions are correct. Now, I've explained this to people, to apprentices before, and they've said, well, you know, what if I'm doing a mitered top? If I got mitered corners, so the top of your frame is going to look like this. My father would kill me. My father's a draftsman. He'd be shouting now at the screen going, use a bloody rule, for God's sake. I'm not gonna. Right, so we got a frame like this, and we got a leg coming down here. So this is box section. And what they're saying is that you can use this method. Hang on, I'll draw the other leg in it. You can use this method if you've got mitered tops. Well, you can, of course you can. You know, this piece, you know, you just leave that piece out. So your frame, essentially, or your frame sides, my dog that is. She thinks I'm talking to myself. Your frame sides would look like that, and then these pieces go in after. Now, alright, you can weld underneath here, but you know, believe me, it really doesn't matter. You know, in fact, if this is being designed to take a lot of weight, this setup here is wrong as far as using box section or any section. You could use channel that way, or you could use universal column that way. But if you're using box section to carry weight, you should be doing this. Yeah, let me start a new one. If you're using box section to hold any sort of weight, considerable weight, your frame should be designed like this. There. So that your leg carries through and the leg supports the weight in this direction. Alright, like I said previously, cross members are only designed to stop movement that way. They're not designed section, steel section is not designed to take weight that way. It will bow. Yeah, so if you're doing a frame with anything of any sort of considerable weight on it, this is the way you need to be designing your frame. These legs need to come through the top, you know. Alright, and another apprentice told me that, what if I'm doing a tubular frame? So how can I draw it now? Your frame, oh god, you'll get the idea now. Oh god. Right, so there, that's not bad. So your frame is god, that's awful, isn't it? Your frame is like that. Alright, and what he's saying is, how do I measure to this corner? Well, you don't. What you do, if we look in a plan view, you put your tape into that corner and read it from the apex of that corner. Simple as that. Your tape will go into that point, no problem at all. Your tape measure will. And the same that way. So you go inside. Doesn't make a difference as long as you're measuring the same points. Yeah. I hope it helped. I know there's a huge sort of range of people that are classed as fabricators, from guys that do jig assembly work to guys that do sheet metal, and people that do frames and whatnot. And it's very difficult. You've got to have a lot of you either got to have had a lot of jobs or been very lucky and worked somewhere where they do a vast range of stuff, you know, to know this. I was very lucky. I worked somewhere that you know, one day you were making perhaps you know, complex developments from 1 mil stainless, and next day you'll be doing some 8-inch pipe, and then the day after you may be doing a 6 or 8 meter frame. you know, every frame, then you'd be, you know, perhaps the day after you'd be, you know, using 150mm plate. So I was lucky, and I got a great deal of experience on a wide range of things. I've got a few videos on sheet metal development, on developing more complex things, but I may well do a little series on sort of basics of site development more than anything. I've seen there's a few videos out there of people doing it on drawing boards and, you know, in the workshop. But it's a different ball game when you're outside and you haven't got you know, a vast array of tools, and you need to develop something quickly or whatever. And you know, it's some handy little tips. So I hope you enjoyed this little video. I hope it helps, because like I said, you know, when you start a new job, and the first thing they do to ask you to do is to build a bench, and you stick the top of your bench on the floor like that and start trying to level legs like that, then straight away, you know, they got the sort of measure of you. You know, you come in, build 2 frames like this, boom, boom, you know, and they know that your talents can be applied on a much larger range of things. So remember, they're not just asking you to build a bench. You know, they're trying to find out what you can do. And but just for a bit of you know, info, when I started, I moved from sheet metal to heavy engineering, and I went in and I built my bench like this, just like that. And I was lucky because somebody took me under their wing and said, look, you know, this is what you need to do. And I'm glad they did. But not, you know, there are places where people don't do that. They'll stand by and laugh, you know, or they'll say, you know, he's no good. He's no good on big stuff. But so there we go. Hopefully it helps somebody. Right, I'll see you next time. Before I go, what I probably should have explained was the level of accuracy that this method uses. An old tool maker's method of checking a square. I don't think right, I'll draw it. Before the times of computer measurement systems and CMMs and whatnot, if a tool maker was checking a square for squareness, what he would do is he'd take 4 cylinders or four rings or 4 discs of exactly the same diameter, and he'd take a square and he'd pop them 1, 2, 3, 4, and then he'd take his mic, and he'd mic across there, and he'd mic across there, right? And if those dimensions were the same, then he'd know that square was square. And the beauty with this method is your error is doubled. So there's no reason when you're building a big frame, you know, of any size, why you can't be square within 0.5 millimeter. Because if you're measuring say 302 across there, and you're measuring across the other diagonal 301, yeah, so they're easy to read. There's no reason why you can't read, you know, the difference between a millimeter on a tape. You know that frame, let's try it. You know that frame is only 0.5 millimeter out. you only need to move that 1/2 millimeter, yeah, to get these two numbers the same. So it's really accurate. And I mean, there's no reason why you couldn't interpolate, you know, millimeters and be accurate to within you know, 1/4 millimeter. So there we go. But there we go. If you want to check your square, I've done this, and I've done it with bearings, because bearings got very accurate ODs, and you can check your square. There we go. See you next time.